Okay, what did you guys see? So we're on the first page. This one was the divergent. What did you see? We did this one together, so I lied. I'm sorry. This one we did together. You only noticed a tiny movement, right?
Hardly noticed.
Hardly noticeable. No earthquakes, nothing else for 10 years. Then after 100 years, we had a little more movement. Yeah, and there was only one that we noticed, right? All right, what did you guys say for 1,000 years? Okay, so we still were, the GPS moved further. And you said many earthquakes. Did anybody else notice anything else going on for the 1,000 years? Did you have anything more in your boxes? What'd you have, Chris? I don't think that was in 1,000, was it?
No.
Okay, so that, are you giving me the 1 million? Okay. Is that where, did water start coming in at that point?
No. No.
Okay, so this one was just a valley started forming. Yep.
Okay.
Yep, we can still have a valley underwater, but was this one underwater?
Oh.
No, not yet, not here yet. So what else did you notice for the 1 million? Okay, so we had more earthquakes. And what about the movement? Yeah. The GPS moved a lot. All right, 5 million. What did you start seeing is happening there? So water filled the valley. Is that what you want to say? Okay. What else happened to the valley? Yeah. Yeah, valley got wider. What else happened 5 million years ago? Okay, let's hold off on that one. We're gonna go and watch them to see, did anybody else notice that? You did? Okay. We're gonna hold off on that because I want to see what that actually is. I think I know what it is. I want to make sure we write down this exact thing. By the way, do you guys have all of this?
Yeah.
Like for this one, you talked about the valley forming. Okay, here you said that the water filled the valley. Did you mention that the valley got wider? If you didn't, you need to add it. What about for earthquakes?
A lot more.
Yeah, so even more earthquakes. And what about the GPS? Any other bullets there besides the abandoned River Valley one? Okay. All right. How about the 20 million years? All right. Here we had our first shot at a volcano. Yeah. So volcanoes. What else? Oh, so now where was the ocean? Which used to be the valley.
Oh, there was underwater.
Turns into ocean. So there was regular volcanoes and underwater. So volcanoes, underwater volcanoes, valley turns into an ocean. Yeah, we'll go back and look so we can debate it. We'll go back and I'll show you, there was a hint. I'll show you the hint once we go back. Guys.
2:00.
Yeah, it's at 2:00 today. Oh, it's tomorrow, thank goodness, because I was gonna lose my 12th period if it happened during 12th period. What else? What about earthquakes? We didn't mention earthquakes. Was there none? You didn't see a single earthquake? I was gonna say, are we watching something different? How many earthquakes were there over that 20 million years? Too many. I'm gonna say tons.
So many.
Yeah, so many earthquakes. And what happened with the GPSs? GPS super far away. Super duper, super far away. Awesome. Oh, I forgot to put, this was supposed to go here. Valley, water filled the valley. Let's watch it. So let me go ahead and move that while we, I'll do it first, sorry. Getting distracted. I know, I'm amazing. That should have been over here, water filled valley. I'm gonna leave over here. I'm gonna put it back once that dries, but I just use an excessive amount of and over here, ocean formed in valley. All right, let's watch it and see. So we had a few debates, and I also think you guys may have missed a thing or two. Let's go back. Hi.
Donna was with me.
Okay.
She's legal.
She's legal. I didn't doubt it. Thank you.
Nice. Thanks.
No problem. Oops, I picked the wrong thing. Don't watch this one, but all right, go back to home. Which one were we doing? Let me see if you can remember. Wait, which one?
Divergent.
Divergent. What happens with the plates in Divergent? Which way do they go? Out. Okay, just making sure you remember that. All right, let's watch this 20 million and see if we can solve some controversies. Is it a river or is it an ocean? Let's start with that. So here, or a lake.
No.
There's a hint.
Where?
I see it. I know it's an ocean.
So why? Cause it's got oceanic lithosphere.
That's the reason. So notice, we're just right. Just because you're right does not make you a teacher's pet.
Yeah, we just try it.
Okay, but
nobody like.
anyway, here's this mud-colored lithosphere here, which if you read the key, that's continental lithosphere. So when it started off, it was all that. They were all continental lithosphere the whole way across. Then when these started splitting, let's play it again so you guys can see when that started popping up. Okay. So here's the valley, still none there yet. There we go. So it did start happening in the 5 million, I believe. So let's do the 5 million. I think when we just do 5 million. There it is. So it does happen.
That's where you can see that.
Oh, yes, right here. And that's what I thought you were looking at. This does look like the abandoned riverbed. It's not. So I don't know why they ended up right? I'm not wrong. That can't be an abandoned riverbed down here. Oh, you're noticing it up here?
Yeah.
Oh, you're noticing it right there. So somebody else pointed out that is this color yesterday.
How is it abandoned if it's literally right in it?
So no. So I think if we do consider that, which I can I'll buy that looks like it was, so maybe it started off as a riverbed. And then when it started pulling apart and ocean lithosphere started showing up, it got so big, I mean, we went from a riverbed to, it probably looked more like a lake at first until it eventually turned into an ocean. So basically, an ocean formed during this divergent plate boundary. So we need to make sure that so right here, this was, oh, I still use too much. Valley grew, oh, way too much, wait out. That says Valley grew. Did you add that Valley grew to yours?
Oh, I even had
Okay. So an ocean formed here. That's why I said out loud a couple times.
I can read it.
All right, this is Valley grew, if you can't read it. Let's double check. Let's check for your convergent plate boundaries, what you had to say. And I believe I had you guys, I did not give you these exact instructions to do this, but we did add, yeah, it did work out perfect. If you did it like this, you should have had some notes when a continent hit a continent. Oh, then you should have had some notes for when a continent hit an ocean. So ocean hitting a continent. And then two oceans hitting each other. And you only had to tell me the 20 million year stuff. What was so impressive with the continental? What was happening that day? Yeah. What happened? Did we have earthquakes? Let's start there.
Yeah.
Okay, everybody saw earthquakes?
Mountains.
Earthquakes. Mountains formed.
The lithosphere overlapping.
Okay. Yeah. Oh, yeah. So, okay. So lithosphere overlapped. We're going to just watch the continent hitting the continent one again to see that. And let's watch it. So we're gonna go back, share, home. That was continent. We'll run the 20 million. I was gonna do it anyway, so we're good. So we've got totally mountains forming. We've got the earthquakes, like you said. And here we have, they are one. Notice right here, what's happening here?
They're like overlap.
They are overlapping and kind of piling up on each other. I like to say they're getting thicker. So we can add that if you don't already have it. Did you notice, was there any oceanic lithosphere in there anywhere? Nope. I'll show you back to that screen real quick. No oceanic lithosphere. It's all the continental. Oh, okay. So just, do you have them labeled though? Okay, just make sure they're labeled and clear. Continent, lithosphere. Yeah. That's fine, as long as you know. Sounds good. Ocean continental, what'd you guys see with that one? There was some earthquakes.
Valley in the water.
There was
Water in the
so
valley.
earthquakes and mountains. Actually, did you guys just say mountains? I was zoning out.
No.
You said volcanoes. Hey, where were the volcanoes? Guess we better watch it. All right, let's watch it.
Yeah, there was some.
Let's watch. Hang on, I gotta switch it over to ocean continental. It's a good question. Let's see. Let's see who remembers what they watched yesterday the best. It was yesterday. So we got earthquakes. Notice the earthquakes are on land. Mountains are on land. There's the volcanoes.
I like the water.
The water Ooh, where's the oceanic lithosphere doing?
I think it's going under and then
It's-
it's making it bigger, so then the land rises up and mounts.
You think that's what's happening? I think you, yep, that's the valley Drake mentioned right there. There is underwater valley. I can't think of those are commonly called trenches, but I did not expect you to know that yet. This is not the Mariana Trench, but hold on. So let's add this because you guys noticed a few things that I didn't write down yet. So where were the volcanoes? Yep, they're on the land in the mountains. You said underwater valley, which I agree that is called a trench. You did not need to know that. That's something you would have learned now. By the way, guys, these are like notes. So if yours don't have all this information, add it. And I think that's good. Oh, no, we had one more thing. What did you say about the ocean crust? Ocean lithosphere, where was it going? Went down under continent. Should have given next year, bigger boxes next year.
Or just 3 cents.
Yes, probably 3 separate boxes, all on one page that said convergent. Next year, new plan for next year. I guess since I already clicked the button, let's watch it before you tell me. Home from ocean, 20 million. So now here we go. We got 2 ocean plates hitting each other. What are you seeing? Okay, so one of the lithospheres is going down. You mentioned a new trench and volcanoes. Now you guys said, were there I was talking, let me do it again. You said there was, oh no, that was a different one. Never mind. So run. So earthquakes. And there we go. There's those volcanoes popping up. This is the Mariana Trench, because the Mariana Trench is when there are 2, it's out in the middle of, it's in the ocean. So 2 ocean plates hitting each other. Guys, what could eventually happen with these volcanoes here? They could form new land. This is the, if these are the Mariana, if this is the Mariana Trench, that would be the Philippines then. So the Philippines are like islands that have formed from volcanoes. Same with even Japan. Japan has happened because 2 crusts have hit each other, these volcanoes pop up, and they become so big that you can then live on them.
Only if we live in Phoenix.
Only if we lived in Pangea. Travel would be a lot different.
One step for you.
What are we doing? Stop screen share. So ocean, you should have mentioned. Earthquakes. Volcanoes. You probably would have called it an underwater valley again. If you wanted to call it a trench, you can. You called it a water valley, that works. And then I think you guys mentioned that the ocean crust went under the other. All right, last one. What did you see with transform? Earthquakes.
Yeah, shifts forward and back.
And you said river changes path and abandoned riverbed. Let's watch it, make sure we didn't miss anything. So we got this nice, beautiful river traveling over both plates. We see them sliding past each other, lots of earthquakes. And that riverbed goes with the lake or with the plates. So as one end is moving one way, the other is going the other, we end up with a new path for the river. And that riverbed eventually gets abandoned. And then we have the new, yeah, it's sad, right? Here's what we're going to do now.
Oh. That's actually kind of related.
Okay, I'm gonna move on. I have got no words. We're gonna move on. Here's what we're doing. Yeah, that's what I got. So here's what we're going to do. I asked you guys to grab some highlighters. If you would like to use different colors for different things, you can, but here's what I want you to do. You're going to highlight every time you see the word volcano
Got it.
in your reading. Or in your notes, I mean. So I'm gonna do them in pink because that's a lot like lava colored to me. I'm gonna do green every time I see an earthquake. I am going to do an orange every time,
Why don't you orange?
because I think pink is more like lava.
That
No.
makes zero
So
sense.
you do you. You do you. This is going to be a mountain, and hopefully, I know I lied, I told you to get 3, but hopefully you have somebody near you who has a different color. I'm gonna do yellow for trenches. So again, you're just gonna grab your highlighter. Every time you see the word earthquake, you're gonna color or highlight that in your earthquake color.
Yeah, and I can't really do it. That was absolutely terrible.
Yes, trench or valley. I'm sorry, we called it valleys originally. That should only take you a couple minutes. If you're not done, wrap it up in a minute or so. Taking a look at what you've highlighted. Oh, can you need a little more time?
Terrible. You just can't type.
Okay, I'll give you a little bit longer, not even another whole minute. Okay. What did you notice?
Lots of earthquakes.
Lots of earthquakes. Earthquake happened in all 3 scenarios, right? What else did you notice?
Valley.
Okay, there's some valleys. They were limited. They weren't in all of them.
And like. On the non.
Alright. Volcanoes, where are they? They're kind of. We only have volcanoes in a couple as well, too, right?
Yeah.
Okay, we're gonna keep that in mind. And we're going to now grab your reference table, which you were supposed to already get out, but some of you have trouble reading the board and doing what it says. All right, we're gonna grab page 5 of our reference table. We've looked at page 5 before. Page 5, we used it for latitude and longitude back in the day. Like back in the day, like in September and October. Way back in the day, but I had always told you to kind of ignore what was going on in the background of the map, and we just used it to locate different places. Not yet, not anymore. Now you have to stop ignoring the background, and you'll notice in the background are all the plates. So they, instead of labeling it just North America, it's labeled the North American plate. Eurasia, which I think if you use your imagination, you can gather that Europe and Asia are both on the same plate. So you'll see that the plates are designated. They're all nice and labeled. And then we got a bunch of arrows. And a bunch of other symbols. And there is a key on the bottom here. So we've got, actually, let's not look at the key yet. Let's look at just what the arrows are doing. Let's take a look at the alluvian trench up here. Based on those arrows, what do you notice they're doing at the alluvian trench?
We're coming together.
Okay, they're pointing together. So if we're pointing together here. So I already heard some of you know, what kind of boundary is that then? That's a convergent. Then over here, where were we? There was let's go over here to the mid-Atlantic ridge. So we're between North America and this side of Eurasia. What are those arrows doing?
Divergent.
They're going apart. So that's divergent. So it sounds like a few of you have already memorized these. Good news for you this year. Down here, they actually tell you all of this in the key. So we're going to start first with just arrows. Arrows are showing you the relative movement. So guys, do you know what that means? Relative movement?
Like what it mostly does.
What? Say it again.
Like what it mostly does.
It's not quite. What'd you say? It's not really where they're estimated to move or no. Let me use the word in a sentence maybe that makes a little more sense. How old am I relative to you guys? How would you answer that? It's not quite how you would answer it. How old am I relative to you? One word answer. Older. Older, not old, not old. Older. How tall am I relative to Remy? Shorter. Did you guys need to know how old I was? No, you just know that your teachers are older than you. By a lot, yes, but just, you just have. There is no one in their 80s.
Like, no, really?
There is, yeah. I don't want to hear the answers to that. We don't need to name some names. No, there is no teacher here that is in their 80s.
Some of them look like they're very.
Oh, okay.
Okay. He does not mean me. If you now here's where you gotta make sure you don't open it. So these show relative motion. What I'm getting at is it's not going to tell my exact height to know I'm shorter than Remy. You don't need to get out a measuring tool to figure out exactly how tall I am. You just know I'm shorter than him. Same deal here. So why I'm getting at this is let's look at the Pacific Plate. Let's look at the arrows on them. We got this one, this one, this one, that one, and that one. Based on those arrows, would you be able to tell me which way it's moving?
Yeah.
Oh, you could. Because they're all telling you which way it's moving. This one particular and those ones particular. So can you tell me, is it moving north or south or east or west? No, because the arrows are kind of going, this one's going north-ish, this one's going northwest, southwest, northwest, they're all different. So they're not telling you which way the whole plate is moving. They're just showing you what it's doing compared to the neighbor, just like you just looked at me and Remy and you told me how tall I was compared to Remy. So, and then let's bring Olivia into it. How tall am I relative to Olivia? Oh, do you guys not know how tall Olivia is? I'm taller than her. I'm not taller than most of you, but I am taller than Olivia. That's kind of like this, like the Pacific plate's moving in all different directions if we look at this, but you can tell compared to its neighbors, which way it's moving by looking at the arrows. So you don't use these arrows to say it's moving northwest. We just use these arrows to say it's moving away from the plate next to it. So don't use these as like a solid direction, just do them compared to their neighbors. So that's what those arrows are doing. And then on here, like transform, it's showing you that the plates are sliding, like one's going this way and the other's going that way. So they're sliding past each other. Bottom left corner is a good example. Sure, that's a good one. The best, most famous example is right here. The San Andreas Fault, right there, right over in California. You guys ever heard that, that California is going to fall off into the ocean?
Yeah.
Take a look at the map. Is that really what's happening in California? What's California really doing? Not going out into the ocean, but
Part of it's moving this way.
yeah, that very small edge of California, the whole rest of the United States appears to be going this way and California's going up north. So they're telling us
It could eventually basically go.
It's gonna hit after it,
Africa.
Yeah. Alaska. Yeah. So first it's gonna be Canada's problem and then Alaska's problem. So California's heading up towards Canada. And it's not all of California, it's only a little section of it. So- Well, as we discovered it takes a long time, that 20 million years one, and it was not moving all that far. I mean, so we got some time before this happens again. Divergent, it shows the arrows going apart. Convergent, arrows going together. This complex or uncertain, I'm sure someone knows what's going on there, but we're 10th graders and we don't need to know. So that is too difficult to understand at our point in our education. And then we got these things called mantle hotspots, which you'll see a few of them around, which we'll get to. The Canary Island has, where is it?
Right.
Top?
That's like.
Oh, right there. Sorry, there we go. Canary Island hotspot. There's quite a few. Yep, Hawaii is a hotspot. So we'll get to what those are in a couple days. So this is what you're going to work on Monday. I have one more kid that needs one more dentist appointment. So that's where I'll be on Monday. That's where I was this last Monday. And that's where I was a different day when I wasn't here. It's a long story. I don't want to get into it. But anyway, you're going to be using this map to answer some questions. Since we have a couple more minutes, I want to make a few more connections. Can you go and look at a whole bunch of the convergent plate boundaries? See if you notice anything similar about, hey, you got highlighters. Grab a color and let's highlight some convergent plate boundaries. It doesn't matter what color. So convergent, what kind of symbol am I looking for? Solid black line with little boxes on it. So let's highlight those. Little triangles, I think those are rectangles. I wouldn't say that, yeah, rectangles. I'm not sure they're triangles. Are we looking at different things?
We were looking at them.
Okay, good, because there ain't no way these are triangles. Okay. Oh, okay, yeah, those are different. So notice all of that, the stuff that you just highlighted. A whole bunch of them have names. What are all the names of all the convergent plate boundaries? They're all trenches. The ones that are labeled at least are all trenches. Alluvion Trench, Mariana Trench, Tonga Trench, Peru Chili Trench. Does that like sit with what we just did at the beginning of class? Do trenches form at convergent plate boundaries? Let's check what we highlighted. Did trenches form at convergent plate boundaries? They do. So trenches form at convergent plate boundaries, and that's even labeled. It's not like, doesn't like scream it at you, but if you look at every single convergent plate boundary that's labeled, it's labeled a trench. One more thing you don't quite have to memorize, you just need to know where to look. All right, let's do the same deal with what?
Either way, the point you have to do is portion thing.
No. All right, let's do the same thing with the divergent plate boundaries. Do you notice anything about these divergent plate boundaries? They're all labeled ridges, or the ones that are labeled ridges. Anything else you're noticing here? Where are they all?
And those are-
They're all in the ocean. What did we just do with our divergent plate boundary in that simulator that makes this make sense? What happened after 20 million years in our divergent plate boundaries? Created an ocean. So these have all been doing their thing for 20 million years at least.
Well, technically speaking, in like 40 million years, we can have another ocean.
Could mean, technically speaking, another 40 million years or 20 million years, we could have some more ocean. So no homework tonight. You will practice with this on Monday.